Hello everyone, welcome to Chemazon-Complete Chemistry. In today's video, we are going to learn how to calculate the intensity ratio of different signals in the mass spectrum based on the different number of halogens that are present. That is, we will find out intensity ratio if there is one halogen present, that is 1 Br or 1 Cl, and then in compounds having two halogen atoms, that is either it is two bromine atoms, two chlorine atoms, or one Cl, one Br. And then we will see for compounds having three halogens, that is two Cl, one Br, two bromine, one chlorine, three chlorine, and three bromine. Okay, so let us first understand what is the number of isotopic signals. How do we identify the isotopic signals and how many number of isotopic signals that we will get? So number of isotopic signals is equal to n. What is n? N is the number of halogen atom. Number of halogen atom or number of halogens. Now suppose n is equal to 1, that is one halogen is present. So what we will get? We will get one peak for M plus ion, that is molecular ion peak will be there, plus there is one halogen, so there will be one peak of one isotopic peak, that is M plus 2 peak. Okay, M plus is going to remain constant, that we will get to see in all the spectra. This is the isotopic peak. Okay, here it is one halogen, so we'll get one isotopic peak. Now suppose if there are two halogens, n is equal to 2, then we will get three, total one molecular ion peak and remaining two isotopic peaks, M plus 2 and M plus 4. Okay, which are the isotopic peaks? These are the isotopic peaks. Suppose n is equal to 3. For n is equal to 3, what we will get? We will get one peak for M plus ion and three isotopic peaks, that is M plus 2, peak for M plus 4, and then peak for M plus 6. So now we will understand why there is a difference of plus 2 in all these isotopic signals. Okay, for that we have to understand this table. This is a table for the isotopic composition, or we can say natural abundance. What is the natural abundance of isotopes or naturally occurring? What is the percentage of the naturally occurring isotopes? We are interested in chlorine and bromine. Okay, we will see in the next video for other heteroatoms. This is useful. This chart is useful to identify the heteroatom as well, like in a particular compound which heteroatom is present, that also we can identify by studying this table. So how do you calculate the intensity ratio? Suppose there is one Cl atom. Okay, Cl, you can see there are how many isotopes of chlorine? There are two isotopes. One will be seen at M plus and another is M plus 2. There are two isotopes of chlorine. You can see one is 35 Cl, another is 37 Cl, that is chlorine having atomic mass of 37. So how do you find out the ratio? 35 Cl is to 37 Cl. What is the percentage that is given? 75.5 is to 24.5. Now if I want to find out the ratio, how will I find out the ratio? Divide both the numbers by the smallest number. 75 and 24, which is smallest? 24.5. So we'll divide this by 24.5 and also divide this by 24.5. So we get the ratio. How much is the ratio? 75 divided by, let's say this is approx 25. So 25, 3s are 75, and this is for 35 Cl and this is 37 Cl. So the ratio is 35 Cl is to 37 Cl is how much? 3 is to 1. Okay, so always remember, now we will find out the ratio. In finding out the ratio, you have to remember 35 Cl mass is how much? The relative abundance. This is what this is also called as relative abundance. Relative abundance. This is 3. For 35 Cl we will use 3 and for 37 Cl it is 1. Okay, similarly for bromine also we can find out. Suppose there is one bromine atom. There are how many isotopes of bromine that is present? Again there are two isotopes, 79 Br and 81 Br. Okay, 79 Br is to 81 Br. Here you can see the percentage is how much? One isotope is slightly higher, 50.5, and another is slightly lower, 49.5%. So we'll divide both of them by 49.5. Okay, you can see approx the answer will be how much? Approx you can say the answer will be 1.1, 1:1. Answer will be 1:1. So for bromine, you have to remember that 79 Br we will write as 1 and 81 Br is also 1. That is, the ratio is almost same. Intensity means the height of the peak that we will see in the mass spectrum, then you will understand in a much better manner. Okay, so first let us start with one chlorine. One chlorine we saw just now, M plus and M plus 2. One halogen, so there will be one isotopic peak. So there will be, this is what, this is 35 Cl, this will be 37 Cl. Okay, only one possible combination. So here this is what, this is 3:1. This we calculated just now. Now if there is one Br, then there will be 79 Br or 81 Br. Only two halogen atoms, two isotopes are possible, and ratio we calculated just now, that is how much? 1:1. This is for M plus ion peak and the second one is for M plus 2. Okay, you can see there is only one isotopic peak because there is only one halogen. Okay, now let us see how to calculate if there are two Br. Okay, number of isotopic signals is equal to number of halogens. This we had already seen. Now 2 Br, now we can have different possibility. One is a molecular ion peak, another we will get is M plus 2 and M plus 4. Here there are two halogen, so there will be two isotopic peaks. Okay, now M plus means we have to keep use the lowest mass of the isotope. Okay, two Br atoms are present, so both the Br we will take the lower value, that is 79 Br. Both the Br with the atomic mass 79. Now what we have to do, we have to increase the mass by 2 units. Okay, how we can do? Either I do plus 2 here and I will keep this as same, or another possibility is I will keep first one same and another isotope I can increase by 2 units. So here you can see there will be two possibilities. One is I will keep 79 Br as it is. Second one I will increase by 2 units. Or another possibility is first isotope I increase by 2 units and second one I will keep it as same. Okay, what is the goal? M plus 2. So overall mass should increase by 2 units. Okay, here both were 79. Any one of the isotope we increase by 2 units. Okay, and last one, M plus 4. So we have to increase the mass by 4 units. So M plus 4. So we will increase the mass of the M plus ion peak by 4 units. That is, both the isotopes will take plus 2. Okay, that is 81 Br and this will also become 81 Br. Now remember the ratio, 79 Br is to 81 Br is how much? 1:1. Okay, so now how do you find out the ratio? You multiply, take the value of 79 Br 1 into another is 79 Br, another isotope is 79 Br, so 1. Okay, this is for the M plus ion peak. Then this line means you have to take ratio like this. Okay, then 79 Br is 1 into 81 Br is 1. Now in between the other possibility, what we will do, we will add. Again 81 Br is 1, 79 Br is 1. Line means you take ratio. And then last one again 81 Br is what? 1 into 81 Br is 1. So this is the ratio. 1 into 1 is 1. 1 into 1, 1. 1 plus 1 is 2. 2:1. 1 into 1 is what? 1. So bromine, you have to remember, for finding out the intensity ratio for bromine, we can use what? We can use Pascal's triangle. We can use Pascal's triangle, the one we use for finding out the intensity ratio in 1H NMR spectrum. What is Pascal triangle? You write 1, then 1, 1, and then 2. Okay, first you take 1:1. Okay, then 1 middle number you have to add both the numbers above. 1, then 1 plus 2 is 3, 2 plus 1 is 3 and 1. Then if there are 4 halogen, 3 plus 1 4, 3 plus 3 6, 3 plus 1 4 and last is 1. In this way we can use a Pascal triangle to find out the isotopic ratio for bromine. Now for 3 bromine you will see when there are 3 bromine atoms we will get this ratio 1:3:3:1. Okay, this was for 2 bromine atoms. Now let us see if there are 2 chlorine atoms. Again there is this molecular ion peak and 2 isotopic peaks, M plus 2, M plus 4. Now again M plus means we have to take the lower isotope. So lower isotope in chlorine is 35 Cl. So both the chlorine we will take 35 Cl. Okay, then M plus 2, we will increase the mass of any one of the isotopes by 2 units. I will, let's say first I increase this by 37. I will keep the second isotope same. Then next case, first isotope I will keep same and second isotope I increase by 2 units. Okay, then last is increase both the isotopes by 2 units, that is 37 Cl and 37 Cl. Okay, so how do you find out the ratio? Again 35 Cl is to 37 Cl. What is the ratio? 35 Cl is 3, 37 Cl is 1, so 3:1. Now 35 Cl is 3, so multiply 3 into 3. Line means ratio. Now 37 Cl is 1, 35 Cl is 3. Okay, plus if there is another possibility you add 35 Cl is 3, 37 Cl is 1. Then line means ratio. 37 Cl is 1, so 1 into 1. So this will be 3 3s are 9, 3 1s are 3, 3 plus 3 6, and 1 into 1 is 1. So the ratio is 9:6:1. This is when there are 2 chlorine atoms that are present. Okay, so this was for 2 chlorine. Now 2 halogen, there is last one possibility, that is 1 Cl and 1 Br. Again we will have M plus 2, M plus 4. Okay, so this one you can try by yourself. Pause the video and do it by yourself the way I have done, and then you can cross check your answer whether it is correct or not. Same way we will do for 3 halogens. Now M plus, 1 chlorine and 1 bromine. So we will use the lower isotope of both the atoms, 35 Cl and 79 Br. Okay, M plus 2, how we will do? Increase one of the isotope by 2 units, 37 Cl, and another isotope I will keep same, 79 Br. Other possibility, first isotope I can keep same, and 79 plus 2 is 81 Br. Okay, then M plus 4 means increase the mass of both the isotopes by 2 units. Okay, 35 Cl is how much? 3. 79 Br, all the Br is 1:1. Okay, only you have to remember that 35 Cl is 3, remaining 37 Cl, 79 Br and 81 Br, all these are what? These are 1. Okay, line means ratio. 37 Cl is 1, 79 Br is 1. Then another possibility means plus 35 Cl is 3, 81 Br is how much? 1. Ratio 37 Cl is 1, 81 Br is also 1. So what is the ratio? Ratio is 3 1s are 3. Then 1 into 1 is 1, 3 into 1, 3, 3 plus 1, 4. So 3:4:1 into 1 is 1. So this is the ratio when there is 1 chlorine and 1 bromine atom that is present. Now we move on to 3 halogen atoms. Now 3 halogens means there will be 3 isotopic peaks. One will be M plus and 3 isotopic peak means M plus 2, M plus 4, M plus 6. So this is going to be a little difficult, but you concentrate and you will get the answer. The same way we are going to do, only there are 3 halogens. M plus means keep the mass of all the isotopes same. 2 Cl means 35 Cl, lower value we will take because we want M plus ion peak. 35 Cl and 79 Br. M plus 2. Now M plus 2, what we can do? We will get now 3 possibilities. At one time we can increase the mass of all the 3 atoms one by one. So first, let's say I make 35 Cl as 37 Cl. Remaining 2 isotopes I will keep same. Second case, the second isotope I can increase by 2 units. Remaining 2 I will keep same, 35 Cl, 79 Br. And last is the third isotope I will increase by 2 units. And the remaining 2 I will keep as it is, 35 Cl, 35 Cl. Okay, this was for M plus 2. Now M plus 4, what we can do? Now 2 atoms we have to increase by 2 units. Third one we will keep same. So let's say I will increase the mass of first 2 isotopes first, 37 Cl and 79 Br I keep as it is. Now let's say middle isotope I keep same, 35 Cl, and remaining 2 I will increase by 2 units. 37 Cl, 79 will become 81. Now the top one I can keep same, 35 Cl, remaining 2 I will increase by 2 units, 37 Cl and 81 Br. And last is M plus 6. So plus 6 means increase the mass of all the 3 atoms by 2 units. So 37 Cl, 37 Cl, and third one is 81 Br. Now what will be the ratio of this? 35 Cl is 3. So 3 into 79 Br is what? 1. Okay, 3 3s are 9. Okay, now M plus 2, 37 Cl is 1, 35 Cl is 1, sorry, 35 Cl is 3, 79 Br is 1, plus 35 Cl is 3, 37 Cl is 1, 79 Br is 1, plus 35 Cl is 3, 35 Cl is 3, 81 Br is 1. Okay, is to 37 Cl is 1 into 37 Cl 1 into 79 Br is 1. Another possibility, so add 37 Cl 1, 35 Cl is 3 into 81 Br is 1, plus 35 Cl is 3 into 37 Cl is how much? 1. 81 Br is also 1, and last is all of them are 1. So 1 into 1 into 1. Okay, solve this. 3 3s are 9. So 9 is to 3 1s are 3. 3 1s are 3. Plus 3 into 3 is 9. So 9 plus 3, 12. 12 plus 3, 15. 9 is to 15 is to. Then third is 1 into 1 into 1, 1. 3 into 1, 3. 3 into 1, 3. 3 plus 3, 6. 6 plus 1, 7. And 1 into 1 into 1 is 1. So this is the ratio when there are 2 Cl, okay, 2 chlorine atom and 1 Br. Okay, I hope you have got this answer. Now 2 Br and 1 Cl. Again you try by yourself. We will have 3 isotopic peaks. One is M plus, another will be M plus 2, third one is M plus 4, next is M plus 6. Okay, 2 bromine atoms. So M plus means keep all of them the lower value, lower mass, 79 Br, 79 Br and 35 Cl. M plus 2, first I will increase the mass of 79 Br, that will be 81 Br, remaining 2 I will keep same, 79 Br, 35 Cl. Now second isotope I will increase, let's say 81 Br, and remaining 2 I will keep as it is, 79 Br and 35 Cl. Now the third one I will increase by 2 units, 37 Cl, and remaining 2 I will keep as it is, 79 Br, 79 Br. Now M plus 4, let's say first one I keep same, 79 Br, and increase the mass of other 2 by 2 units, 81 Br, 37 Cl. Now middle one I will keep same, 79 Br. First and third I will increase by 2 units, 81 Br and 37 Cl. Now last one I will keep same, 35Cl. First two I will increase by 2 units, 81Br, 81Br. And last is M plus 6. So increase all the mass of all the atoms by 2 units. So 81Br, 81Br and 37Cl. Okay, find the ratio. 79Br is 1. So 1 into 1 into 35Cl is 3. Okay, now 81Br, 71Br, Br is 1 into 1 into Cl, this is 3, plus Br is 1 into 1 into 35Cl is 3, plus 79Br, Br is 1 into 1 into 37Cl is 1. Ratio, again Br is 1 into 1 into 37Cl is 1, plus 1 into 1 into 37Cl is 1, plus 1 into 1 into 35Cl is 3. Last is 1 into 1 into 1. So this is 3 into 1, 3. 3 is 2. 3 ones are 3, 3 and 1. 3 plus 3, 6, 6 plus 1, 7. 1, 1 and 3. 3 plus 2, 5. And 1 into 1 into 1 is 1. So this is the ratio when we have 2 bromine atoms and 1 Cl. Okay, similarly we can find out when there are 3 chlorine atoms. M plus 2, M plus 4, M plus 6. 3Cl, M plus, so use the lower mass atom of lower mass. Lower atomic mass in Cl is 35Cl. So 35Cl, 35Cl, 35Cl. M plus 2, again do the same exercise. Increase the mass of any one of the isotopes. Let's say middle one. The first one I have increased, the remaining two will be same. Now next is middle one I will increase by 2 units, 37Cl. Remaining I will keep as it is. And third case, last one I will increase by 2 units. And first 2 atoms I will keep same, 35Cl. Now M plus 4, what we can do? First I will keep the first atom as same, 35Cl. Remaining 2 I will increase. Next is middle one I will keep same, 35Cl. Remaining 2 I will increase, 37Cl, 37Cl. And last is third one I will keep same, and remaining 2 I will increase by 2 units, 37Cl, 37Cl. Last is increase the mass of all the 3 atoms by 2 units. Okay, so 35Cl is what? 3. So 3 into 3 into 3. Line means ratio. 37, 35, 35. So 1 into 3 into 3, plus whenever there is another possibility you add plus 35, 37, 35. So 3 into 1 into 3, plus 35 is 3 into 35, 3 into 37 is 1. Okay, then line means ratio. Now M plus 4. M plus 4 means, again we will do find out the ratio. 35, that is 3 into 1 into 1, plus 37, 35, 37, that is 1 into 3 into 1, plus 37, 1 into 1 into 3. Okay, ratio, line means ratio. All are 37, so 1 into 1 into 1. This will be 3 3s are 9, 9 3s are 27. Okay, 27 is to, this is 9, 9, 9, 9, 9, 9, 9 3s are 27. Okay, 3 3 3, 3 9s are, sorry, 3 3s are 9. And last is 1. So this is when we have 3 chlorine atoms. Okay, last one is when we have 3 bromine atoms. Okay, 3 bromine atoms. Again we have M plus 2. Remember I told you to remember the Pascal's triangle. 1 2 1 1 3 3 1. So we should get the answer as 1 is to 3 is to 3 is to 1. So let us see we are getting the answer or not. M plus 4, M plus 6. This also you can try first by yourself. Okay, M plus means we will keep all the atoms lower value, 79 Br. M plus 2 means increase the mass of any one of the atoms. 81 Br, 79 Br, 79 Br. Then middle one I will increase 81 Br. Remaining 2 I will keep same. Third one. Now last one I will increase by 2 units, 81 Br. Remaining 2 remains as it is. Okay, M plus 4. Now first one I will keep same. Remaining 2 I will increase by 2 units, 81 Br. 81 Br. Next, the middle one I will keep same. And remaining 2 I will increase. Okay, we are always comparing with M plus ion, that you have to remember. Here we are adding plus 2. Last is the third one I will keep same, 79 Br, 81, 81. And last case, increase the mass of all of them by 2. 2 plus 2 plus 2 is how much? 6. Okay, now Br is 1. So we will write 1 into 1 into 1. Then here again 1 into 1 into 1 plus 1 into 1 into 1 plus 1 into 1 into 1 ratio. Then again we will repeat plus 1 into 1 into 1 plus 1 into 1 into 1. Last is 1 ratio 1 into 1 into 1. So this will be 1 is to 1 plus 1 plus 1 3. Similarly 1 plus 1 2, 2 plus 1 3 and 1. So this is when we have 3 Br atoms. Okay, we can see it is the same as that of the Pascal triangle. So when remember, only whenever there is only Br atoms present, okay, then only you can use Pascal triangle. Okay, if there is if at all only one atom is also Cl, then you cannot use this Pascal triangle. Okay, we can use Pascal triangle only when there are bromine atoms, no chlorine atoms. Okay, so let us see whether from the mass spectrum, let us confirm whether we are getting the same ratio. This is 1 Cl. 1 Cl I told what was the ratio? 3 is to 1. Okay, so now this one, if you see 50 is at which value? You can see it is at 100. Okay, so this is 100. So this another will be 1/3 of this. So that means approx 33%. Okay, so this one you can see it is around here. Okay, 20, half is somewhere here. So this you can see it is approx 34 or 33 to 34. Okay, this is 33%. This we consider 100. So this will be relative. Relative means if this is 100, this will be 1/3 of that. 3 is to 1. 3 is to 1 means 3, if you divide by 3, then we will get 1, right? Similarly, 100, if you divide by 3, we will get 33. So you can see M plus peak is at 100% and this one is 33. So for example, let's say the height of this peak at M plus ion, this is what? This is, let's say, 9. Okay, approx, let's say this is 9 centimeter. So this other peak, it will be divided by 3. That will be 3 centimeter. Okay, this was for 1 Cl. Next is, let's say, 1 Br. 1 Br we had found out the ratio was what? 1 is to 1. So you can see this is the isotopic peak. So it is approx, it is same. We had seen one of the isotope was what? One of the isotope was slightly higher. So that is why the peak of the mass at 94 is slightly higher than that of M plus 2. Okay, the natural abundance of 81 Br was 49 point something, right? And that of 79 Br was how much? It was 50 point something. So slightly higher. That is why this is almost 1 is to 1, but little bit difference. So this was for 1 Br. Next is 2 chlorine. Okay, 2 chlorine, what was the ratio we had got? 2 chlorine, the ratio we had got was 9 is to 6 is to 1. So this is M plus, this is M plus 2, 102 is M plus 4. So this is a molecular ion peak and 2 isotopic peaks. Okay, so here if you see the ratio, this is what? This is If I zoom this, you can see it will be approx. What was the ratio that we had got for 2 Cl atom? 9:6:1. Okay, so let me zoom this. So here you can see 98 is approx, you can see it is 9, slightly lower, that means 6 is peak at 100, and then very lower, that is peak at 102, that is M plus 4. Okay, this was for 2Cl. Now 2Br. 2Br, what was the ratio? 1:2:1, Pascal's triangle. Okay, again this is M plus 2, M plus 4. Okay, two isotopic peaks. Okay, let me zoom this. Okay, peak at 86 is, you can say, let's say it is 1. Then double height of that is 188. That is peak at M plus 2. And then M plus 4 is again same as that of the 186. That is 1:2:1. So in this way we get the intensity ratio. And then, okay, here also you can see, this is, let's say this is 1. So height you can see it is same. And this is the double of this, so 2. So 1:2:1. In this way we get the intensity ratio. Okay, last is when there is one bromine and one chlorine. One bromine, one chlorine, the ratio is 3:4:1. Okay, so this is M plus, this is M plus 2, this is M plus 4. Let me zoom this. Okay, so M plus is 3. Slightly above, that is 4 is 144, that is M plus 2 peak, and 3:4:1. Very lower is M plus 4. Okay, that is 3:4:1 ratio. Okay, the zoom version is here. So this you can consider 3. Slightly higher is 4, and very lower is 1. Okay, so ratio is what? 3:4:1. Okay, for 3 halogens we are not seeing the mass spectrum because it will be very complicated. Okay, so this is what, this is the summary. Okay, summary of the ratios. If 1 Cl, 3:1. If 1 bromine is present, 1:1. 2 bromine, 1:2:1. 2 chlorine, 9:6:1. 1 chlorine, 1 bromine, 3:4:1. 3 bromine, 1:3:1. 3 Cl, 27:9:1. 2 chlorine, 1 bromine, 9:15:7:1. And last is 2 bromine, 1 chlorine, that is 3:7:5:1. So here we come to the end of this video. In the next video we will see how to identify the heteroatom based on the natural abundance table that I had shown in the initial slides. So I hope you have understood this video, how to find out the intensity ratio. This is a very, very important topic asked in almost all the competitive exams, NET, GATE, many times it is asked. Okay, we will also solve the previous year question in the coming videos. So you solve it by yourself. First you see how I have solved, then all the different cases you solve it by yourself. Then only you can come to know whether you have understood the topic or not. Okay, you solve by yourself and then you check the answers. Okay, total there are 10 possibilities. So all the 10 possibilities, what you have to do, you have to solve it by yourself, then check the answers. If you're not getting the answer, then you check where you have done the mistake.